Domain and range was where we left off. What do you remember? That could be a loaded question, right? Do we remember anything about domain and range? If you flip back to the front page, I had a little bit of information. Henry?
Domain is the X and the range is the Y.
Okay, so domain is the X, range is the Y. We're looking at these graphs, yes. And so in all of my graphs, I was labeling X-axis and Y-axis because we were thinking X and Y, right? So if we start talking about domain, domain are the X's. On a graph, where are the X's? The X-axis goes which way?
Side to side.
Side to side, left to right. Okay, so how far left does this graph go?
Infinite.
Infinite, because it's not on here, but you guys have learned, right, that there's arrows there. I just didn't get them on there. Okay, so as that graph is, this one's decreasing, going down. As it goes down, it's going left. So it's going infinitely left. How far right is it going? Infinitely. So what kind of answers could we give here?
Negative infinity.
Okay, interval notation, negative infinity to positive infinity. This one they would probably just have you give interval notation. Okay, but then it's all real numbers, or X such that X is a real number. Okay. When it comes quiz test time, I'll take any of those. So all real numbers. Fancy brace with X such that X is a real number. Or interval notation, which we go infinitely left, which is negative infinity, infinitely right, which is positive infinity. And if you recall from last week, infinities always use parentheses. Okay, I try to keep repeating that stuff just so hopefully it'll be stuck in your head when you go to do homework. As I went through, I think I was looking through the homework, kind of getting it set up, making sure I had the problems I wanted to. And I noticed they'll tell you in the directions of each problem, but sometimes they want interval notation, sometimes they want an inequality. I don't think they ever went with the fancy set notation, okay? They would just maybe want like an inequality such as like y greater than or equal to 0. So those will be the two options. You'll just have to watch the directions. Okay, so that's domain. Now we got to talk range. And it reminded us range are the y values, so we're going now up and down. How low do we go?
Infinite.
Infinitely down, yes. So if we're talking interval notation, negative infinity. How high do we go?
Be less than 5. It'd be like 4 1/4.
I agree with less than 5, not quite 4 1/4, but 4 1/2. Just because every other line is a whole number, so I'm going to go with that's 4 1/2 in between. Okay, so if we go with the interval notation, it went as low as negative infinity. Infinities always use parenthesis, comma. How high did we go? 4.5. Is the graph touching the y value of 4.5? Yeah, this point is at a y value of 4.5. It's at a height of 4.5. We touch that. So if we touch it, we use brackets. Okay? Now, inequalities. Let's talk less than or greater than. Or less than or greater than what number?
4.5.
4.5. How are we going to write it? Is it less than or greater than 4.5?
Lesser than?
Less than? Less than or less than or equal to?
Less than.
Less than or equal to, because it does touch 4. Anytime you have a bracket, you're going to use the equal to part. Now, fancy notation. Just to get you guys used to it, I'm going to put the brace, y, the bar that says such that, and then here's the part that you have to be able to write. Y less than or equal to 4.5. Okay? So on this problem, if they ask for interval notation, you would do answers like those. If they ask for an inequality, you would do an answer like that. I don't think they'd ask for an inequality here. They would just say all real numbers. Like it would be a multiple choice type and you'd pick all real numbers type thing. Okay, I can't remember exactly their wording, but okay, so you guys get a little bit of review of domain and range here, okay? Moving on, we've got to keep moving today. I'm fearful we might not quite make it through and we've got to. Okay, next topic, x and y intercepts. When we talk about x and y intercepts on a graph, that's where your graph crosses the x-axis or the y-axis, okay? It's just what it sounds like. So x-intercept is the x-coordinate of a point where the graph intersects the x-axis. Good vocabulary to realize, x-intercepts are also called the zeros of a function. So that's a good vocab word. You might see like in a standardized test or something where they ask you to find the zeros. So just, connect that a zero on a graph is just where it crosses the x-axis. Y-intercept, of course, is the y-coordinate where the graph intersects the y-axis. Now, if you think about all those points, x-intercepts and y-intercepts, they all have one thing in common. And if I flip back here for a moment, okay, like if we look at this point here, okay, if we were to look at any of these points where we cross an x or a y-axis, one of that two numbers in that ordered pair is always going to be a
Negative.
No, not negative. If it's on an x or a y-axis, there has to be a zero involved because it's either going to go left or right zero or up or down zero, depending on which one we're talking about. So the easiest way to find intercepts, and this is when we have equations. Obviously, if you're looking at a graph, it's really easy to be like, oh, it crosses the x-axis there, or it crosses the y-axis there. That's easy. But when you have an equation, easiest thing to do, substitute 0 in place of the other variable. Okay? So it's a good thing to learn and remember. So let's start over here. Our first example is y equals the absolute value of x minus 3. And I'm going to start us, we could start either way. I'm going to start us with finding the x-intercepts. Intercepts, could be 1, could be 2, who knows. Now, if we're trying to find the x-intercept, we want to know where it crosses the x-axis. So we're trying to find the x value, which means we're going to let the other number be 0. So in order to find an x-intercept, we're going to let y equal 0. Okay? So to find x, you get rid of the y. So I'm going to put 0 in for y. So 0 equals absolute value of x minus 3. Okay, basic equation solving here. How do we solve for x?
Get it to its own side.
Yeah, if we've got absolute value of x minus 3, we want the x by itself. In order to move that 3 away, we're going to add 3 is the easiest way. Okay, so when you add 3 to the other side, 0 plus 3 is 3 equals absolute value of x. Okay. Absolute value of x. Do you remember what absolute value means? What's absolute value of x absolute value normally do to something?
Make it positive.
Makes it positive is general rule of thumb, right? Now, so officially, the definition for absolute value is the distance from 0. Think. What numbers can go in place of x?
1.
No. The absolute value of what number would, in this case, equal 3?
Negative 3.
Could negative 3 go in here? Yeah, because the absolute value of negative 3 is going to be 3 from 0. So 3. What else could go in here besides negative 3?
Positive 3.
Positive 3, yes. So this is a situation where we have two answers. Okay? X could equal positive 3 or negative 3. Now, We could write this one of two ways. You guys familiar with the plus or minus sign? Okay, you could write plus or minus 3. And when you are in Savvis, the plus or minus sign is usually something you can find in their toolbar somewhere. So that is an option. Or the other option is just write 3 comma negative 3. So my x-intercepts are 3 and negative 3. Okay? Whether you write it as plus or minus 3 or 3 comma negative 3. Okay. So there could be 2. There's not always going to be 2, but there can be 2. That's my x-intercepts. We also need to find our y-intercept. Well, if I'm trying to find where we cross the y-axis, what's going to happen when we cross the y-axis? X will be 0. So we're going to let x be 0. So start over, same original equation. You just replace x with 0. So y equals absolute value of 0 minus 3. Well, absolute value of 0 is 0. 0 minus 3 is negative 3. So we have a y-intercept of negative 3. And it's not that you'd have to write out the word y-intercept. I'm just doing that so it's labeled and you know what it's what. Don't let me put the wrong answer though. Jeez. Okay. The hardest part about x and y intercepts is just remembering how to find them. I feel like that's always the thing, is getting students to remember, like, stick that in their brains. Okay, you just put zeros in for the other variable. If you can remember to just put zeros in, it really is an easy thing. Okay, let's use our other equation here. G of x equals 4 minus x squared. First of all, what's g of x the same as? It's fancy speak for what variable? The hint is, what do we not have in this equation? We don't have a y, okay? F of x is our normal one. This is g of x. Whether it's f of x, g of x, h of x, whatever, that is just a fancy way to say y. So this equation is really just the same as y equals 4 minus x squared. Okay? That's all it is. Now, how am I going to find my x-intercept? Put 0 in for y. Okay? X-intercepts happen when y is 0. So I'm going to say let y equal 0. And again, I'm writing out extra stuff just as reminders, so when you look back at your notes, you'll be like, oh yeah, that's what we did here. Not that you have to write it all out, but 0 equals 4 minus x squared. So I put 0 in for y, got rid of y. Now I just have x. What are we going to do?
Subtract 4.
Okay, one option is subtract 4. Then if we subtract 4, what's going to happen there? We're going to have negative 4 and negative x squared. What can you do in that case? Don't square root yet.
You can make them both positive.
Make them both positive, right? It's the idea of technically you'd be dividing by negatives or multiplying by negatives. In other words, if both sides are negatives, basically you can flip them to positive. What's the other option of what we can do here? He had said what? Subtract 4. We could also what? Not subtract, but if it's minus x squared, we could add x squared. Okay. Does it matter technically? As long as you can get there, right? As long as you can get there. Personally, for me, I would have said if it's minus x squared, I would add x squared. So 0 plus x squared is x squared. Here we have 4 because minus x squared plus x squared cancels. Okay. One way or another, you are at the point where you have x squared equals 4, right? Or 4 equals x squared. How do I find x? Someone said it, I just wasn't quite ready for it at the time.
Square root.
We're going to square root, yes. Remember when you have x squared, to get x squared to become x, you square root. If you square root the left, you do the same to the right. You got it. The square root of x squared is x. What's the square root of 4? Is that it? Is the only square root of 4 2? Could -2 work? Because what's square root mean? A number times itself, right? 2 times 2 is 4. Also, -2 times -2 is 4. So you have options again. You could write it as plus or minus 2, or you could write it as 2 comma -2. I think Savas is pretty, sometimes Savas gets nitpicky, a downfall of having online. Sometimes they're pretty flexible. Okay, you should be able to enter it as either plus or minus 2 or 2 comma -2, but those are options. So that's my x-intercepts, excuse me, and there won't always be 2 x-intercepts, just the way it's working here. What about y-intercepts? How do I find my y-intercepts? Yeah, we're trying to find y. We want to get rid of x. So let x equal 0. So in this case, go back to my original equation. Y equals 4 minus x squared. Y equals 4 minus 0 squared. Tough math on a Monday morning. 0 squared. 0. 4 minus 0 is 4. Okay. So we have a y-intercept of 4. Now, happened to just pop into my head, so you're going to get the advantage of it. In most of the homework questions, when I was going through them the other day, they would just say, what is the y-intercept? And you just type 4. What is another way to express a y-intercept of 4? There's another form that they ask for it at least once in. If we're looking at a graph.
4/1.
No. What? Not that fancy. Just what is this as an ordered pair? X was 0, y is 4. So if they ask you for an ordered pair, realize this is 0, 4. Could they do that? They could. Okay. It's the learning curve of Savas. You have to watch the directions. What about they ask, what about x-intercepts? What would those be? Well, no. Think 2 different ordered pairs. When x is 2, y is 0. Or when x is -2, y is 0. So, let's see, can I fit it in? You could have the, so I was afraid I'm too low. You could have the ordered pairs over here of 2, 0 and -2, 0. Okay, so just some notation. Just trying to not totally throw you off when you look in the homework and whatnot. Okay, questions there? Okay, moving on. Okay, our next topic here is identifying positive and negative intervals. So where is my graph considered positive and where is my graph considered negative? So if you look up there, have a little bit of information. Positive intervals happen when the y value is positive. Well, when is the y value positive? Think about when the y-axis is positive. And the y-axis is positive when we are above the x-axis. So when we start talking about positive intervals, you're looking for when the graph is above the x-axis. And I will tell you, they usually give you a graph, or you can make a graph to answer this question. So positive happens above the y-axis. Where's negative going to happen then? Below the x-axis. Okay, that's when your y value is negative. Now, the key is, how do we write this? Okay. That's the key here. So let's look at this first example. Y equals x squared minus 9. X squared graph. Parabolas. They like the parabolas here. Yes. You guys realize there's technically arrows there, right? And what do we have here? We have an x-axis and a y-axis. So we're looking at, when is our graph positive and when is it negative? Well, what's the dividing line? The dividing line is the x-axis here, right? That's my dividing line. So, where's my graph going to be positive? In general, it's going to be positive where? Above. So it's going to be positive in those two little pieces. Okay. So it's going to be positive over here, and it's going to be positive over here. We'll talk about how to write that. Where's it going to be negative then? It's going to be negative below, yes? So all of this is going to be negative. Where does it change from being positive to negative and being negative to positive? Where does it change at? At the x-axis. What values are those? Where's it changing at? Yeah, right here it crosses the x-axis at 3. Over here it crossed the x-axis at negative 3. So that those negative 3 and positive 3 are key points, because that's when my graph changes from positive to negative and negative to positive. Now, we're going to start with negative. I'll come back up here and do positive in a moment. Just because I feel like the negative is going to be a little easier to grasp here. Now, I feel like they only did interval notation on this. So I think I'm just going to focus on interval notation. When you give your answers, okay, we're giving our answers in terms of x. Okay, because as the graph moves left to right. So when is my graph negative? From what x value to what x value? It started being negative at what? Negative 3. And then it's negative, 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 negative. When does it stop being negative? At 3. Okay, so I'm going to use interval notation. And it's negative from negative 3 to positive 3. Now, is my graph negative at negative 3 and positive 3? Technically, what values would those be? They're the x-intercepts. So this is 3, the y value is 0, and this y value is 0, yes? So are negative 3 and 3 included? No. So I'm just going to use parentheses. It's negative from, that's an interval. That's not an ordered pair. That's an interval. Started at negative 3, ended at positive 3. Okay? Now, let's go back and talk positive. When is my graph positive? So, what would you say about this section over here? When is that positive? That's positive what? Before we get to negative 3? What kind of numbers are below negative 3? Negative 4, negative 5, negative 6. How far do we keep going? Infinitely, yes? So this graph is positive here. It started way over yonder, okay? It's positive from negative infinity to, when does it stop being positive? Negative 3. So we're going to use negative infinity. I put it there without asking. What do I always use with infinities? Parentheses. So negative infinity to negative 3. Negative 3 again, itself is not positive. It's a zero value. So that's why I'm just using a parenthesis. I'm just going to say comma here. In between is what the homework will do. When else is my graph positive? When does it start being positive again? At positive 3. So it starts being positive at 3. When does it stop being positive? Never, right? Infinity. So 3 to infinity. Infinities always use parentheses. And again, at 3, 3 is neither positive nor negative. So I'm using a parenthesis. 3 has a value of 0, if you will. Okay, that was a little different. We could also write these as inequalities, folks. I don't remember seeing that in homework, so I'm not going to do it right here because I think it's more stress than it's worth. Okay? Shall we try the next one? Yeah, if you have a question, let me know. Okay? Okay. Got a different one here. Plain old line. They gave me the equation. If you're given an equation in homework at all and you don't know what it looks like, I'll show you guys tomorrow. Just go to Desmos and graph it. We'll practice that tomorrow a little bit. But y equals 2x plus 10. Again, we have an x-axis and a y-axis. This is a line. Guess what? It goes on infinitely. And we want to know where it's positive and where it's negative. Where's it going to change between being positive and negative? It's going to change at the x-axis. What important point is that? 5, technically a negative 5 if you look closely. Or just note that it's to the left of 0. Okay. So we can do whichever one you guys want, but we're going to talk about where is my graph positive. And we're going to talk about where is my graph negative. Visually, you guys got it, I'm guessing. That's not the hard part. It's how do we put it into the description. It's negative when it is below the x-axis. So there it's going to be negative. Where is it positive? When it's above the x-axis. Oh gosh, that was horrible. We'll just leave it like that. So above the x-axis is positive there. Okay. Which one do we want to start describing? Negative? I was kind of thinking that. Okay, where's my graph negative? Not partially. So negative 5 is our dividing point, yes? In terms of left and right of negative 5, where is it negative? To the left of negative 5, right? Like if you think, I'm trying to make my hand a vertical line here. Okay, if you think of that vertical line, to the left of my hand is where it's below the x-axis, right? And so to the left of my hand are numbers that are smaller than negative 5. So if they're smaller than negative 5, it's numbers that are less than negative 5. How do we write that as an interval notation? To the left of negative 5 is not going to be positive infinity, but it's going to be negative infinity. So we're going to use negative infinity up to negative 5. Infinities always have parentheses. What about negative 5? Parenthesis. Because at negative 5, the graph isn't negative or positive, it's 0. Okay, so We come from the left, we come from negative infinity. We cross -5, now my graph is positive. So we cross -5, and we keep going to the right. How do we write that? At what point did we start being positive? -5 to what?
10.
Not just 10 though.
Infinity.
Positive infinity. We're going to keep going. Okay? Okay, sorry. Oh my gosh, the comma was not looking like a comma, and it was bugging me. Okay. Got a little bit of an idea of what's going on here, right? The homework will test you, and I'll be available for questions tomorrow to help too. Okay? And I know it's hard to get a grasp on it until you do it on your own, but okay. One last main topic. Yeah, because the back is just a chart to kind of summarize everything. One last topic. We got this. The last type of question we're going to talk about is when is a graph increasing or decreasing? Okay. Now, my notes only cover increasing or decreasing. Technically, I'm going to throw in here or constant. Okay. Just because they throw the constant question into the homework several times. Nothing really comes of it, but I need you to be familiar with that word, because otherwise, if I don't mention that word now, you're going to look at homework and be like, we didn't talk about constant. So we're going to talk about it as we go here. Okay. Something's increasing. What's it doing? It's going up, yes? So a function now, officially it says a function is increasing if the y value is increasing. So if your y is your guinea figure, you're going up. As the x value increases, just saying as you're moving to the right on the graph. A function is decreasing when? When you're going down, when your graph is traveling down. So your graph is traveling down when the y value is decreasing. Okay, again, it says as x value increases, but that's just saying as you move to the right on the graph. Okay, now, increasing, decreasing, constant. What's constant mean? Stays the same. So what's a constant portion of a graph going to look like? Horizontal. Okay, I just need to throw that in. A lot of times, the homework will say, when is this graph constant? And there's no constant parts. There's no horizontal parts most of the time. Okay, so I don't even know that you ever get to answer yes to that, but I wanted you to see it, have the idea. Usually we are either increasing, going up, or we are decreasing, going down. Okay, so for what values of x is each function increasing or decreasing? Notice my answers are going to be given in terms of x's. So it's as we read the graph left to right. Okay, so y equals 2 minus absolute value of x. It's an absolute value of x, so it's a v graph. It's an upside down v. And it's raised up 2. All because of the stuff going on there. Okay, as always, all these graphs have arrows. Okay. As I start, I'm going to always start on the left side of these graphs. As I start on the left, what's the first thing my graph is doing as I go from left to right? It's going up, yes? Everyone agree with that?
Mm-hmm.
And it's going to go up, and it's going to go up to that peak there, which mathematically, another word I need to throw in here, that's a maximum. Okay, that's a max. So I think the homework asked a question about that. That's a max. So this is the increasing portion of the graph. Now, when did my graph start increasing? Well, it started increasing not just here at -4, but infinitely to the left, yes? So it started increasing at, guess what? Negative infinity. Okay, because it's from the left, it started increasing at negative infinity. To, when does it stop increasing? Stops increasing when it hits that top point, right? That max point. What's the ordered pair for that max point? Reverse it.
0, 2.
The max point there is 0, 2, yes? I already stated we're doing this in terms of x value, for what values of x. What is the x value there? 0. So when are we increasing? We are increasing to the x value of 0. Okay? We went to a height of 2, but we don't care about the height right now. We're asking, when do we stop increasing? We stopped increasing when we hit that x value of 2. Well, infinities, guess what? Parentheses. And that 0 point, we're increasing to it. It's just it's going to be a parenthesis again too, because it's also going to be the point that we're going to turn around and start decreasing, right? Okay, are we good with the increasing? We hit that max point, and as you hit that max point, now we're going to start heading down the graph. My y values are now getting smaller. Okay, so this is my decreasing portion of the graph. When did we start decreasing? The same place we stopped increasing, right? Those points are always going to overlap unless there's not connected. Going to be a parenthesis again. Now, in terms of x values, how far to the right are we going to be decreasing? Infinitely to the right. And that is a positive infinity. I know we're going down, but we're moving to the right, which is what we're talking about here. So that's why we're using positive infinity. Okay. Was there any constant portion of this graph? No, because I never went horizontal. Okay. We increased, we decreased. This point, if I want to throw in a vocabulary word, this is a max. And why is it a max? Because we went from increasing to decreasing. Seems logical enough if you ask me, but I'm the math teacher, so I try not to assume too much. Okay, we got to move. Okay, I got to speed up. As we start at the left side of this graph, we're going to always start at the left. What am I doing first? You're going down, we are decreasing. Where are we decreasing to? Well, it's a y value of -4, but officially it's the ordered pair of 2 -4, correct? So it goes to a level of -4, but at what x value do we stop decreasing? At 2. So can you guess how we're going to write this answer? We are decreasing from, we started way over in Mr. Arnold's room. So we started decreasing on the left, negative infinity, to the x value of 2, parenthesis. Guess what happens after we stop decreasing? We start increasing. Okay, we increase, we increase. You got thoughts on what this increasing answer is going to be?
It's going to be infinity.
2 to infinity. Read left to right. So we're going to start increasing at 2. And then we're going to keep going infinitely right. So 2 to infinity. Okay. And it does have to be in that order. Okay. Now, was my graph ever constant? No. And guess what this point is called? This point is called a minimum. A minimum happens when your graph changes from decreasing to increasing. Okay, one last one. I start at the left. What's my graph start doing?
Going down, decreasing.
Decreasing. When do we stop decreasing?
I don't think you do.
Good answer. We don't. It's decreasing the whole way. When did it start decreasing?
Infinity.
Negative infinity. When's it going to stop decreasing? Positive infinity. So we are decreasing on the interval. This is interval notation again, right? We are decreasing from negative infinity to positive infinity. So, when Savas says, when are you increasing? You're not. When are you constant? You're not. You are decreasing the whole time. Okay? Now, one other piece I want to throw in here, and I may need to talk about this tomorrow, but right here, if they ask you, this is function notation, if they say, what is g of 2? You guys remember that? G of 2 is going to equal, what's the y value? -4. They threw that in a random question on homework. So we can talk about it tomorrow. The back page that we didn't quite get to, this is just kind of a summary. Okay, so we got through everything. This is a summary. iPads, have them here, charged, ready to use, ready to log on the internet. Your class, everyone has an iPad, right? Yeah, you guys are all returned. So thank you for hanging with me, guys.